We're starting a new unit called Transformations. Transformations basically are an operation that moves or changes a geometric figure in some way to produce a new figure. Changes that might occur would be the orientation, or how turned something is, the size of something, or how big it is. Another change that could occur, and we won't see any of those in the transformations that we're doing, is the shape of the thing. If it gets morphed or distorted, like you may have seen on some of your Apple products, they have a camera that will distort or morph your face, or whatever you're taking a picture of. Those kinds of transformations are not something that we're going to study. The ones we will be studying are these four basic types you see on the screen here. Translation, you'll notice that the orientation of the object remains the same. This angle of this bottom side of the shape here remains at that same angle. It's got the same slope and everything. So the orientation is the same, and the size and shape are also the same. So the thing itself remains the same orientation, the same shape, and the same size. That is the nature of what translations do. They just move it along or slide it along in a direction and at a certain distance. Rotation, you need to know that, again, the orientation in this case gets turned. So this bottom side here gets turned, and now it's there. That thing got turned in its orientation, but the shape and size of it remained the same. It didn't get bigger or smaller, and its shape is also the same exact shape that it was before. In a reflection, the shape and size again are the same, but this time this side right here gets over there, and so it's not the same orientation that it was before. It's not just turned, it got actually flipped across this line here. The last one then is a dilation. The size finally does get changed, but the shape is the same, and its orientation is also the same. So orientation got changed on these two. Orientation stayed the same on these two. The size and shape stayed the same on those three. The size changed on that one. The shape is the same on all four of them. Basic facts about transformations. A transformation is an operation. Well, here's the definition I just quoted just a moment ago. There are four basic types. There's the translation, reflection, rotation, and dilation. Notice that this is the only one that is not a congruence transformation. The original figure before we do the transformation is called the preimage, and the figure after the transformation is called the image. And here again is the picture of those four things. There's some certain information that we need to know about each particular one, and this video lesson is just going to generally talk about those. So rigid transformations, which I'm actually going to call congruence transformations. So let's change that. Congruence transformations produce congruent figures. So they must have the same shape and the same size, but possibly a different orientation, and most certainly a different position. They won't be in the same place. With a translation, we're going to slide or move a figure along a ray without turning it. This without turning just means that the orientation is going to remain the same. What we need to know is a distance to move it and a direction to move it. That distance and direction can be told to us different ways, but that is the basics of what we need for a translation. For a rotation, we're going to turn a figure around a point called the center of rotation. If you go back and look at the picture from a few screens ago, there was a point that was drawn on the rotation example. That point would have been the center of rotation, and around that point everything got turned. You may have seen an example before where people show you the night sky, and a time-lapse photography of it shows that all of the stars rotate around a fixed point. And really close to that fixed point is Polaris, or the North Star. And since it stays at kind of a fixed point, which is generally where the axis of the Earth points to, it becomes a convenient way for people at night to orient themselves and to find which direction north is. Anyway, this is just an example of how rotation and center of rotation are around a fixed point, called the center of rotation. What we need to know then is, where is the center of rotation? So center of rotation. We need to know how much we're turning it. So angle of rotation. Angle of rotation. I should have put an F there. So center of rotation, we need to know the angle of rotation. And we also need to know whether we're turning it clockwise or counterclockwise. And that's what the CW and CCW means. Clockwise and counterclockwise. If it's not specified the clockwise or counterclockwise part, convention is to just always assume that it's counterclockwise, which is counterintuitive. We would expect that we would be turning it in the clockwise direction. But for some reason, science and nature tells us that it's better if we're going the counterclockwise direction. Okay, with a reflection, we're going to flip, which is probably what you've learned a reflection is before. We're going to flip a figure across a line called the line of reflection. And that will create a mirror image of what the pre-image was. What we need to know is, where is that line of reflection? If we know where that line of reflection is, then we can reflect every point in the pre-image to a point across the line to where the image would be. Please note that in this class, we will only be using the X and Y axes as our lines of reflection, just to make things easier. I forgot to mention when we were talking about rotations that the only center of rotation that we'll be using for this year is the origin itself. That will also make things easier. Okay, there are non-rigid transformations. We should call these similarity transformations. And so similarity transformations produce similar figures. A dilation, it enlarges or reduces the figure by a constant called the scale factor. And this is all language that we should know. We're not going to study this really particularly until next week, though. Okay, we're seeing four congruent triangles here. Triangle A, which is blue, and that would be the pre-image. And then triangles B, C, and D, which are all red, those would be the image. And the question is asking us which one goes to which. So B looks like it's the same shape, size, and orientation as A. That must mean it's a translation. So B is the translation here. D looks like it's a flipped version of it. And it probably got flipped about the y-axis, it looks like, because this corner, where the right angle would be, gets transformed to be over there, which is the same distance away from the y-axis. So I'm guessing the y-axis was the line of reflection, and D is a reflection of triangle A. Process of elimination, we could probably assume that C is a rotation of triangle A. I wonder if we could determine where that center of rotation would be. Well, the whole thing looks like it got turned 180 degrees, and it would have to have been around something right in the middle of those, so somewhere about there. That's probably where the center of rotation would be. I'm not expecting you to find lines of reflection and centers of rotation, because like I said, those would either be the y-axis or x-axis, or else the origin for a center of rotation. What I do want you to be able to do is to recognize whether it's a translation, reflection, or rotation of the object. So here are your practice problems. Decide whether each transformation is a translation, reflection, or a rotation. Let's see, which two should I pick? We'll go with 13 and 14 as the ones that we'll be transferring to our warm-ups.